Hello. This is my third go on recording this. Uh, ugh. The first two goes, I tried to do the internal recording thing from the PowerPoint. How you can record your PowerPoints. Um, but apparently, if you do that, you cannot go back on your slides because it rewrites the audio. Excuse me. So I basically went back to my circuit diagram to explain, but it rewrote the audio to what I explained on that earlier. So I had to redo it, and the first time I didn't understand what didn't work, so I just did it again. And now I'm just recording with an external program to just record my screen. So yeah, this is my presentation on my 555 timer piano. The presentation is obviously by me. So yeah, here. This is my circuit diagram. I don't have much to explain right here. As you can see, in the middle there's the 555 right here. Here are the 8 potentiometers, and I'll come back to that, how I varied that. Here's the speaker and some more fancy business. Oh god, what just happened? Okay. Why is it doing that? Okay, whatever. How did I put it together? This is not including my breadboard process simply because I already covered that in my earlier presentation. Okay, so after that, first I gathered all my components one by one off of my breadboard. But as I mentioned here, organization, I didn't just throw everything off. As I needed them, I took one off after another, so I knew where I had to put them according to my breadboard. I started adding the components in numerical order from the 555. You know how the 555 has 8 pins, 1, 2, 3, 4, 5, 6, 7, 8. I usually started with first pin, then the second pin, then the third pin, etc. As I stated next, if a pin had more than one connection, I would start with the easiest connection. One example would be pin 1 only has one connection, but it goes directly to the positive terminal, which is pretty simple. Excuse me, that's wrong. Pin 1 goes directly to the negative terminal, which is pretty simple. Same as pin 8, it goes directly to the positive terminal. But pins like 7, 6, or 2, they go to several different ones, and I'd choose the easiest connection to do first. I didn't mention this in here because I made a mistake, but after having all my components in the correct order, not soldered yet, on my on my strip board, I checked it again to some pictures on my breadboard and also my circuit diagram, just to be 100% sure. After soldering it, there's not much really to soldering. I just, turned it around, bent the legs so they wouldn't fall out, and then I soldered one by one. Once I had everything soldered, I encountered different parts of it not working. I used a multimeter to check the different connections. After that, it still didn't work. I couldn't find any faults with it. And so I asked other people like Jimmy, you, Mr. Koch, and Grisha to check my circuit for me, and till today we still have not found the proper reason why it doesn't work. Thanks to Jimmy, I found one fault in the main circuit area. Okay, my materials / tools. For the main resistor, potentiometer, variable resistor part to use as the keys, I used 800K ohm potentiometers and 8 switches that would either allow or disallow the current to pass through. I used 2.1 microfarad capacitors, one 10 microfarad capacitor, a large strip board because the small ones from the school could not fit the 8 potentiometers and switches in a row, so I had to go buy another one that's roughly 4 times the size. I also used silver wires, a 1K ohm resistor, a 5x5 integrated circuit plus a socket so it wouldn't overheat while soldering. I also used a 440 ohm loudspeaker that was provided by the school, a 9-volt battery, and a battery case, or rather the connector. I used a thin solder and also a soldering station to solder everything together. And at the end, I used a multimeter to check everything. Check connections, check potential dividers, excuse me, okay. The modifications I made to my circuit are as follows. You see the squiggly arrow. Why is it changing that? Don't do that. Okay. See the squiggly arrow thing that is just pointing at the potentiometers? Well, I don't really like that because I'm assuming that means you can directly connect with your fingers, like manually, to what connection you want to connect it to, what variable resistor. But I didn't like that, so instead of having like a loose connection, I added switches. So one switch to every single potentiometer that was then directly connected to 2 and 6. This is so there's no loose connections, and so to make it an actual piano, so I can actually press buttons in order to make a pitch happen. Oh, my throat hurts. Sorry. Except that the only, as I just mentioned, that's the only major modification I made. For some reason, my keyboard always wants to change it twice. So, how does it work? My 555 is in an astable mode, which I will come back later. Pins 8 here. So, pin 8 is directly connected to positive. It's the positive input. Pin 1 is the negative input. The negative voltage input, and 8 is the positive voltage input. 3 is the output, as I mentioned right here. And pins 2 and 6 are the threshold inputs. Now, the first time I recorded this, I think I did a pretty good job at explaining it, but here, let me try my best. Pins 2 and 6 are a so-called threshold input because depending on the resistance of the potentiometers, this is kind of hard to explain, and I researched this, and it was kind of hard to understand in the first place. So bear with me. The 0.1 microfarad capacitor that's connected to 2 and 6 charges until it exceeds the threshold of the resistance of those potentiometers. Therefore, while holding a certain resistance, the capacitor will charge until it exceeds that threshold. Now, let's say my potentiometer is set to 10K, a 10K resistance. The potentiometer will charge much faster. Well, it will take less time for the potentiometer to pass a 10K resistance threshold than it will take to pass a 100K resistance threshold. Therefore, while holding a button that's connected to a variable resistor with a 100K resistance, oh god, so many words, 100K resistor or variable resistor, it will take longer, thus have a lower pitch because it will have less cycles, less releases of charges, because it takes longer to charge and release before it passes a higher resistance threshold. I hope that made sense. Except for that, there was some funny business with a high and a low state having to do with pin 3 and pin 2, or rather the capacitor on pin 3 and the capacitor on pin 2, that they work together, and something about pin 7 being in charge of an internal transistor that will regulate the high or low state of pin 3. It's too much science. I don't understand it. But the main and the most significant part of this entire thing, I hope I have explained properly. Except for that, also pin 5 was used to regulate and stabilize the potential difference, I think, of the entire thing. That's what it said. But as I said, I don't really understand. But yeah, I already explained the main part of it. Let me just go back to here. So, as I explained, the pitch depends on the resistor between pin 7 and pin 6 and 2. That's why I have 8 different variable resistors set to 8 different resistances, so that for each button with a different resistance, or rather with each button connected to a variable resistor with a different resistance, it will take a different time for that one capacitor to charge up, or to charge up and pass the threshold and release its charge, thus making a different pitch. So, my problems and solutions. At the very start, and at the breadboard, I had planned to add an extra potentiometer that would change the overall pitch of, I don't know where I wrote tune, but of the an overall pitch of the notes. Excuse me. But this wouldn't work because, as I later found out, the human hearing is not set to a linear scale. Therefore, if just adding 10k or 100k ohms to each to then the overall resistance, it will make the notes out of tune. Because it's not like 10k equals note A, 20k equals note B, 30k equals note C, so on. Therefore, 110k won't equal note A, and 120k won't equal note B, etc. It doesn't work that way. It's not linear, and that's why I decided to discontinue that extra potentiometer. Another problem I had was that the main circuitry, this area right here, or rather this area right here, not including this part, didn't work due to this capacitor not being in the right place. It wasn't actually connected to anything. And as I mentioned earlier, Jimmy found that out and he fixed it. Well, Jimmy found it out and then I fixed it. And obviously the solution was to resolder it. Another problem was that my circuit doesn't work. Why? I don't know. We had I think 2 different theories why. The first theory was that there's a cold solder, which I doubt, but it might be true because Mr. Koch, you told me that magically it started working once you entered the classroom, which might mean that there's a cold solder. But you also mentioned that since I set all of these potentiometers to 0, so they had no resistance whatsoever, that it might have fried some component, which is also kind of unusual because the components I'm using aren't very friable. They're not very prone to being fried. But, it might be true. My solution to that is to just take out all the friable, basically replace all the friable components that might have been fried. So yeah, that's actually my biggest problem right now because it still doesn't work. Another problem is that my battery and speaker connections keep on breaking. I think, whatever. Okay, they keep on breaking, and this is because there's only a couple wires like holding a 9-volt battery and a heavy speaker to the entire circuit board, and if you're just handling it all day long or each lesson, they tend to rip. So every now and then they just, they rip and then they don't work. But right now my circuit doesn't work either way, so it doesn't really matter. So I just like resolder it whenever I need to test if it's working now. This is my final project. Just to have an overview, right here, this is my speaker. It goes through this wire over here, connecting to that capacitor, to the 10 microfarad capacitor, and here the positive or the negative side. Oh, here the negative wire connecting to the negative terminal, and this capacitor right here. This is the battery case, also connected to the positive terminal, which is right here. And yeah, here are all the potentiometers, and here are the buttons connecting everything. This is a closer up view where you can see this area right here and all the potentiometers and buttons. One thing I might want to mention that Mr. Koch told me that I should try in order to make it easier to check my circuit. Is instead of having all of this stuff, because all in all this might not work. Maybe this is the only part that's working. So instead of having two variables of things not working, I can just, which I think is visible better here, just connect 7 and 2 and 6 directly with a different resistor instead of having all of this stuff, because it might not work. So I would just unsolder one of these connections and put a 100K or even a 60K resistor in here to check if this part works. In the beginning it didn't, then Jimmy fixed it and then it did work, and now we're not sure if this part works, but it should work because we checked it. So yeah, it's a bit tricky. That's a close up again, and here, this is my bibliography. Actually, I am missing one website as far as I can see. It's actually the website that taught me how the astable thing, like the astable, bistable, and monostable modes of the 555 work. It also explained how the different inputs and outputs and the threshold works. So yeah, I forgot to mention that in here. This first web link right here is the main website where I found my my piano design from, and my second one down here is from it. Why did I just do that? Okay, it's not supposed to do this. My computer's being weird. Whatever. The second link is an interview with you, which is more, you helping me in class overall. So yeah, I'm a bit fed up right now because this is my third try in recording this entire thing, and I hope I did as well as my first time. And yeah, you better give me a good grade.